This video is on the objective perform and interpret a two-mean hypothesis test with population standard deviations unknown. All right, so a t-test, not a z-test. And this is with the calculator. All right, now I've already done a video on this already, but in that video, the population variances were assumed to be equal. So it was a pooled t-test. You'll see in this one, I found another problem where the population standard deviations, the population variances are not assumed to be equal. So it's a non-pooled t-test. All right, with your calculator. So again, let's take a look. All right, so if you want to see more about it, how they're doing it on the calculator, right, just click on more instruction, look at their videos, their notes, their examples, and hopefully those help you out. All right. So here, researchers working for a manufacturer of LED light bulbs are testing a new model of light bulbs to determine whether the new model has a longer lifespan than the current model. The following table shows the lifespans in hours of 10 of the current model of light bulbs and 10 of the new model of light bulbs. All right. Assume, again, big statement right here. Assume that the population variances of the lifespans of the current model of light bulbs and new model of light bulbs are not equal, meaning that this is a non-pooled t-test. Right? I'll keep that in mind when I pull up the calculator later. And that the lifespans for both types of bulbs are normally distributed. All right. Let the lifespan of the current model of light bulbs be the first sample, which you're seeing here, and let the lifespan of the new model of light bulbs be the second sample. So at the 5% level of significance, right, this is alpha, 0.05. Is there evidence that the new light bulbs have a longer lifespan? All right. Perform a test using the calculator. Okay. And then, all we're asked to do here is find the test statistic rounded to 2 decimal places, and then the p-value rounded to 3, right? So put in t equals p-value equals, right? Well, first, I'm going to enter these lists of data. Right? So I'll pull the calculator up. And, you hit stat, edit, and then I'll just do this down L1 and L2. So down L1, I'm going to enter the sample data, the lifespan of the current model. So we have 6,672 hours for one bulb, and I'm going to pause it and come back when all 20 of these are entered. Now I'm going to enter 10 down list 1 for the current model lifespans, and then the other 10 new model lifespans I'm going to enter down list 2. All right, so I'll be you'll just see it pop up in a second. Okay, and I'm back, and you see all 10 of the current model lifespan numbers from the sample are written in L1, and all 10 of the new model lifespans are in list 2. Alright, so before we go into doing the test, let's write some things down, write the hypotheses, the claims, the claim and the hypotheses here. Got a piece of paper out, and now it says this, these researchers are testing a new model of light bulbs to determine whether the new model has a longer lifespan than the current model. Remember, the current model is going to be, remember mu1 here, all the first sample stuff was for the current model, right? So the average lifespan for all the current model light bulbs. And the second sample stuff, which is coming from the second population, the population of new model light bulbs, that'll be mu2, the average new model light bulbs, lifespan. So the claim that they're testing here, what they're trying to determine is if the new model has a longer lifespan than the current model, or if the current model has a shorter lifespan than the new one, right? This is the current has a shorter, less than lifespan on average than the new models. or if you read it the other way around, it's the new models have a greater lifespan than the current model. So this is our claim. And then our hypotheses then, this does not involve equals, so that's in the alternate. That the current models have a smaller lifespan than the new ones, or the new ones have a larger lifespan than the old ones, the current ones. And then the null hypothesis is the opposing statement, right? That mu1 is greater than or equal to mu2. But then when we perform the test, what you're going to be assuming is the equal part. Right? We would assume that they have the same lifespan on average, and then see if we're going to reject this or not. The value of the significance level is, they told us, was 5%, the value of alpha. And we're going to compare this to our p-value once I run the test. So let me pull up the calculator again, and I've got those lists already entered. Let's run this test now, this 2 mean t-test. So go stat, over to tests, and then you saw it in the first video, we have 2 samples and we're running a t-test. And again, it's a t-test because the population standard deviations are unknown. Right? Sigma 1 and sigma 2 are unknown. So I go 2 sample t-test. Then it asks you, do you have 2 lists of data, or are we given the statistics? Well, we're not given the statistics here. But, in older problems, on problems earlier in the assignment on other objectives, you were given all the stats, so you could just go here and enter all the stats and run the test. It'll give you different degrees of freedom, though, right? So I wouldn't recommend that too much, because we're using the more conservative degrees of freedom for when you're in the non-pooled situation. So I wouldn't rely too much on the calculator for those. Anyway, if you're talking degrees of freedom anyway. But for other tests, yeah, sure. Alright, so 2 sample t-tests. We're given lists of data. Now again, list 1 is down L1. That's the current model lifespans for those 10 bulbs there. And list 2 is down L2 for the new model lifespans. Each one's only counted 1 time each. So there's no frequency list. Just keep these as 1. And then this line says, what does the alternative hypothesis look like? Is it a two-tailed test, a left-tailed test, a right-tailed test? It is a left-tailed test. All right, mu1 is less than mu2. Got that here. And is it pooled? Well, remember, the assumption was, they assumed that sigma 1 is not equal to sigma 2. So remember, this is the non-pooled scenario. All right. Non-pooled, and that was back here in the, say assume that population variances, right, are not equal. Okay, so I click on no, make sure that's on no for pooled, and then calculate. And look at what comes up, right? It tells you what the alternative hypothesis looks like. What's the test statistic, the t-score, for the difference in your sample means, negative 2.1. We're asked to round to 2 decimal places, so 196 would be negative 2.20 if you went to 2. And then the 3 decimal places, the p-value, 0.0223. All right, so I'll enter these. So the t-score, our test statistic, negative 2.20, to 2 decimal places. And then the p-value to 3 decimal places is 0.023. Okay, wonderful. And again, they take you through how I did that on the calculator and whatnot. Now, if they had more to it, which they don't, I see the p-value, right, is 0.023. You compare the p-value to alpha. All right. The p-value is less than or equal to alpha, right? This is 2.3%. That's only 5%. That's 5%. This is definitely less than or equal to alpha. And if that's the case, you are going to reject the null hypothesis. All right. So we're going to reject this statement, this assumption, meaning we're accepting the claim. Right? The claim was the alternate. We're supporting the claim. So in the conclusion, we would say there seems to be enough evidence in these samples to say that the new models have longer lifespans than the current ones. So I'll just say that there seems to be sufficient evidence. There is enough, or there is sufficient evidence to support the claim, that the new models have greater lifespans than the current ones. I'll just write to support claim. Okay. Yeah, you'd have to compare the p-value to alpha, make a decision about the null hypothesis, and then state a conclusion about the claim. Do you support it or not? Does the evidence support it or not? All right. Now, again, they're not asking that here. I think that this is the end of it. Yeah. So I know some of the questions they might ask, what would be your decision about the null? Do you support the claim or not? That kind of stuff. What is the conclusion? So just pay attention. Hopefully you've seen enough hypotheses tests now to where you could figure that out. Alright, so hopefully watching my video here, looking at more instruction, reading the answer explanations, hopefully all that stuff helps you out when you go to do this on your own. And thanks for watching.